Hello, I welcome you all in this presentation related with the subject materials processing, fundamentals and practical. And now today we will be starting a new topic that is based on the joining of metals or very commonly known as the welding. But the joining has a much wider umbrella under which many processes which are used to join the things fall in category of the joining, while welding precisely for the processes where the metallic joints are produced commonly by fusion approach. So, in this particular presentation we will be talking about the fundamentals associated with the joining, role of heat, pressure, filler metals, the classification, selection, different types of the processes, etc. So, as far as content is concerned, initially we will be talking about the need of joining or welding, then what are the common approaches used for developing the joints for manufacturing the products, and then the selection of the suitable type of the joint. Like there are various types of the joining processes and the different types of the joints which are developed. So, like joint may be temporary, joint may be permanent, joint which even weaker joints will also be okay, but or in some cases you need very strong joint suitable for one particular kind of loading or other like that. So, what are the various factors which we should consider while selecting suitable type of joint? When the fusion welding is carried out for developing the joints, then we will see that there are many unique things happen with the metals and during the fusion welding process. What are those unique things that affect the joint performance and the joint characteristics? Then the selection of the welding processes, and then what are the mechanisms of joining. Like if we see the general mechanisms, like it can be simple mechanical interlocking like nut bolt rivets etc., or it can be based on the heavy plastic deformation like in friction welding, friction ultrasonic welding, or if it is based on the just the fusion of the filler metal like in brazing and soldering, or it is based on the fusion of the fank surfaces of the base metals to be joined like in fusion welding. So, there are various mechanisms that work for the development of the joints using various approaches, and then classification of the joining process, which means there are tens of the joining processes. So, how we can put the different processes in different categories. So, that is done basically for ease of understanding and giving the names to the newer processes. There are various purposes of classifying the joining processes. What are the various factors based on which the joining processes or welding processes are classified, and what is the advantage or the purposes of classifying the joining processes. Then also we will try to see what is the role played by the heat, pressure and the filler metals in welding and joining. Okay. So, initially we will start with the need of the joining. Okay. So, see the joining you can do using various processes, like we can simply use the adhesives for developing the adhesive joint, or we can just melt the filler metal between the two components to be joined like in soldering or brazing. So, there is no melting of the filler metal. Okay. Then we can go for melting the fank surfaces of the base metals to be joined. So, that we do in case of the fusion welding. Okay. So, see there are variety of the ways by which the joints are developed. Okay. And all these processes are used primarily for the two purposes. One is in the manufacturing. So, manufacturing the products. Okay. Like if you have to manufacture very large size components which cannot directly be made by casting, forming or only by machining, then what we do, we make the components and parts in simple shapes and then we join them together to make very large size systems like ships, pressure vessels. So, one is like for making the very large size parts, products and systems. Another, the reason behind use of the joining in manufacturing is like making the complex shape products. Okay. Like relatively simple shapes we can make by casting, forming, but if it is very complex and very large, then those processes, those conventional manufacturing processes are not found to be workable. Then what we do, we use the joining. So, joining for manufacturing very complex shape products and parts. So, this is as far as these two are the like broader purposes for which the joining or the welding is used. But there is another set of the purposes where like there is already part, okay, but part has stopped functioning properly due to the continuous wear and tear, okay, or it has cracked or it has fractured. So, in order to bring back the adversely affected part due to the service or anything else, repair, reclamation or refurbishment of the component or the broken part is done. So, depending upon the purpose, what we do, if the component has lost its dimensions during the service due to the various types of the wear mechanisms, then loss of dimension will make the component work improperly, okay, and so that will be leading to the failure of component. So, what is done? We try to restore the dimensions and shape. So, for this purpose what we do? We do the reclamation, okay. In reclamation what is done? The layer of the material is deposited, or layer of the compatible material is deposited over the surface, and then it is machined out, so that the dimensions are restored. There is another application where we see if the material of which component is made is not very good resistant to the wear, then what we do? We try to build up the layer of the another good quality material over the surface of the component, so that it offers good wear resistance. So, either whether it is good wear resistance or good corrosion resistance. So, for that purpose what we do? Weld surfacing and cladding is done. So, this is the weld surfacing or cladding is simple, like deposition of the metal using suitable welding process, okay, and then we can machine it out to produce the desired dimensional accuracy and the shape which is needed. And then the welding is precisely the fusion welding processes can also be used for enhancing the surface characteristics. So, like say this product has been made by casting having very coarse grain structure, and the surface properties are not really good, or if it is having the defects near the surface. So, what we do? We use the TIG arc or laser beam or electron beam, any non-consumable heat source process like TIG, tungsten inert gas welding, or the laser beam or electron beam. So, these are directed onto the surface. So, that will be causing very rapid and quick melting followed by the solidification. So, when this is done, the structure gets very refined and the defects are eliminated. So, the two things happen: defects elimination and refinement of the grain structure, and this happens due to the melting of the near surface layers, so that the surface defects or near surface defects are eliminated. So, when grain structure is refined, defects are eliminated using these the laser beam or electron beam or TIG or the plasma, then the surface properties get enhanced. So, these are the common purposes, like one is for manufacturing, either for making very large size components or for making the complex shape components. Another is for the repair or reclamation or for developing the wear resistant surfaces. Okay. So, these are like say the common purposes for which the welding or joining based processes are used. So, approach wise if we see the joining, if it is totally relying on the mechanical aspect, then like say a hole is drilled, and in through this hole what we do? We just use the nuts and bolts like this, okay. So, or we use the rivets. So, in this case basically the mechanical interlocking happens, but the mechanical and based joining process like rivets, clamps, bolts, nut bolts, etc., these do not help in manufacturing the liquid tight or air tight joints, okay. additionally, the use of these mechanical joints tend to increase the weight of systems. So, in the manufacturing of the components and products where weight is very crucial, then the mechanical types of joints are not that preferred unless the reliability demands is very high. Then for the need of high reliability, we may use riveted joints like in the bridges or even in the aircraft wings. Also the riveted joints are used coupled with the adhesive joints. So, mechanical joints are really good, but they increase the weight of the system. Okay. Adhesive joint is another where this between the two components where the joint is to be developed, we place the adhesive, okay, after cleaning, and then we allow it to cure. So, during the curing, the two things can happen: liquid to solid transformation or some chemical reactions will be involved during this curing, leading to the hardening. Okay. Hardening will be happening in both the cases where a liquid to solid transformation takes place in case of the thermoplastic based adhesives or thermosetting based adhesives, where some kind of chemical reaction is also involved during the curing, and that in turn will be leading to the development of the joint, which is reasonably good, not as strong as that of the like the fusion weld joints or the mechanical joints where nuts, bolts and rivets are used. So, for developing the adhesive joints, we may use epoxy resins, for example, Quick Fix, M Seal and the Fevicol. These are typical examples. So, we can use adhesive for developing the relatively weaker joints, but for the purposes where it is important to maintain the relative position between the two components rather than taking the loads. So we can use these for non-structural joints, for developing the non-structural joints where the load will not be coming significantly onto the joints during the service or the operations. Then the welding, where the welding can be done broadly using the approaches like the fusion welding, solid state joining. So, in these cases what is done in fusion welding, what we do, the components to be joined are brought in abutting position or in suitable position, and then edges are using suitable heat source, which may be flame, which may be arc, which may be laser beam, suitable heat source. These edges are brought to the molten state, okay. And then once these are fused, then you see this is the backing plate. Once the fusion takes place, heat source is removed, and so that later on liquid to solid transformation results in the metallic continuity from one end to another. This is what happens in typical fusion welding. In solid state, joints are developed based on multiple approaches, where either macro or micro plastic deformation at the interface, is carried out. This is one, or the second where the two components to be joined are kept in very firm metal to metal contact, very smooth finished conditions, and followed by exposure at higher temperature in vacuum condition, leading to the development of joint due to the diffusion across the interface. So, in that case what we do basically, like the two components to be joined are smoothly polished, finished, okay, and under the normal load they are kept in vacuum at high temperature. So, three things: vacuum, high temperature and pressure. So, when this happens, diffusion across the interface takes place, and that leads to the development of joint in case of the diffusion bonding or diffusion based joining process. So, but in case of the other solid state joining process where either macro deformation or micro deformation is involved, like in case of the ultrasonic welding or in explosive welding, ultrasonic the waves are transmitted at the joint interface, and that leads to the micro level deformation at the interface, which facilitates not just the mechanical interlocking, but recrystallization or also the formation of some kind of the intermetallic compound in case of the dissimilar metal joints, and the mechanical interlocking certainly will be happening. So, in this case the heat generated at the interface is very less, like in explosive or ultrasonic based welding processes, which are solid state joining processes, but in other processes like friction welding, friction ester welding, or your the forge welding. In all these processes, large scale plastic deformation is used for developing the joints. So, significant plastic deformation will be involved in these joining processes in macro deformation based joining processes like in the friction welding, friction ester welding, or forged welding. Okay, the brazing and soldering, these are the two joining processes which are classified as liquid to solid, both liquid solid joining process, where the base metal or parent metals remain in solid state, but the filler metal is brought to the molten state. So, what we do, that components are placed in proper position with the sufficient gap, that is known as clearance, and the component is heated, and here at the ends what we do, we place the brazing or the filler metal. So, which when it melts, it is sucked by the gap through the capillary action. So, it gets distributed. So, the base metals remain in solid state, but the filler metal in the form of brazing material or soldering material, that is brought to the molten state using suitable heat sources. It can be flame, or it can be iron, it can be the molten bath of that relevant metal. So, or it can be induction also. So, using suitable heat source, the filler metal is melted, and then the molten filler metal is sucked into the gap between the components to be joined. Thereafter, on the solidification, a joint is developed. But since the brazing or the filler metals are weak, you see both brazing and soldering filler metals, these are relatively weak as reflected by their low melting point temperature. So, these offers low strength as compared to the direct melting of the base metal by fusion welding followed by the joints. So, fusion weld joints certainly we are offering the higher strength, but they need a lot of heat. Heat damages the material, and that is why these the fusion based processes are not preferred for joining those metals which are very sensitive to the external heat application. And therefore, if possible, if the load requirement, if the structural stresses that will be acting on to the joint during the service, they are not very high, then even the brazing and soldering material, soldering joints can be used. So, like for most of the electronic joining of the components in electronics and the computer system manufacturing, the solder is used, because here what we want, the two parts being joined remain in particular position. So, stresses are hardly there, but the role of the soldered joint is primarily to allow the smooth an uninterrupted flow of current for proper functioning of the systems. So, here since there is no external stresses, so soldered joints will be performing very nicely in development of joints for computer and electronic components. Okay. Since the approach is being used for joining by the mechanical methods using adhesives, by welding, brazing, soldering, fusion welding, solid state joining, in all these cases, the approaches and the mechanisms are different. So, because of this difference, there is no similarity as far as the approach and the mechanism of the joining is concerned amongst all these group of the processes. Okay. Therefore, they do not offer the same load carrying capacity. Load carrying capacity of each type of the joint is different. Reliability of the each type of joint is also different. They are not equally compatible under all conditions, like joining of the same metal, joining of the different metals, joining the joints suitability and working performance in the different working conditions, that will also be different. So, therefore, it is important to see, like whatever type of the joint is made, that is able to take the desired service load, it offers the desired reliability for a consistent performance. It is also compatible for the given service conditions as well as for developing the joints between the two same or similar kind of the material or different materials, and how good it is for performance, for long term performance under given service conditions. So, service suitability is to be checked while selecting or identifying the suitable type of the joint to be used. Like simple here, it is just to give the idea that these are the A and B are the two parts to be joined. So, they are initially in separate condition. So, if the component is very smooth, very finished and flat, then the moment you put them together, they will hold each other without doing anything extra. But the force that will be required to separate them will not be very high. They will offer the joint, but the joint will be weak. Okay. Here in case of adhesive, when the two components being joined by putting the adhesive in between, these offers the reasonably good joint in terms of the strength and the capacity, load carrying capacity LCC. This is low, not very high. These also perform under the moderate or low temperature conditions, low, moderate or the low temperature conditions. Okay. Therefore, these are preferred only under the like normal service conditions, not and for developing the non-structural joints where the load will not be directly coming heavily onto the joints. Okay. The brazing and soldering, where between the two components, the components are heated, then the brazing or filler the solder material is brought to the molten state, and after the melting, when the brazing or soldering material solidifies, it gives us the joint. In fusion welding, the components, edges of the components or the fin surface of the components are brought to the molten state. Thereafter, solidification will be leading to the development of joint in fusion welding. And some kind of the micro or macro level plastic deformation at the edges of the surface is realized through the controlled plastic deformation, and the mechanical interlocking helps in development of the joints. This may be through the macro or micro plastic deformation. And then we can also develop the hybrid joints, like between the two components. What we can do initially, let us place the adhesive, okay, and then develop the spot weld joints, So, here the spot weld is a metallic joint, okay, and around that we have the adhesive joint. So, this is a combination of the two types of joining process. We can call it as a hybrid joining. So, adhesive joint coupled with the spot weld, combination of both. So, this kind of joint allows very good performance, especially under the fatigue conditions. The fatigue performance of this kind of the joint is enhanced significantly. So, as I said, on what basis we can choose and select the suitable type of the joint for making the connections, that will depend upon for the different applications, for making the components, products and systems, we need variety of the joints. Few joints are like permanent, which you do not expect to be separated during the life, or few are temporary, which you may need to separate after some time of service. So, or those which may require frequent engagement and disengagement. Okay. So, this can be temporary or permanent. If it is temporary, then we will be going for the mechanical joining, like we can go for nuts, bolts, clamps, etc. If it is little permanent, then fusion welding is certainly an idea. Riveted joints are also used in that way. Okay. So, we have to see like what is the purpose and whether we want temporary joint or the permanent joint. Like if the joint is to be made in the bridges or in the ship structures, those need to be the permanent ones. So, we can go for riveted joints, we can go for fusion weld joints. Requirement of the service, like at what temperature components will be used. So, this is very important. If the temperature conditions, corrosion conditions, reliability, etc. So, if the temperature is low, then maybe we can use any kind of the joint, but if it is high, then we have to worry about the other aspects, like low temperature, say -30, -40 degrees centigrade, then fusion weld joints of the steel are not preferred because of the very low ductility and toughness under these conditions. Similarly, if the joint has to perform under high temperature conditions, say steel weld joints is to be used 600 degrees centigrade, then we need to see really it retains its dimensions, it does not creep under the high temperature conditions. So, depending upon the temperature conditions, we have to see whether the joint will be able to survive under those conditions or not. For example, if we develop the adhesive joint we cannot use 150 degrees centigrade because they will start decomposing, degrading. Similarly, if the adhesive joint is being used in the in highly moist conditions or under the water conditions, then they will decompose, they will get damaged and the life of the joint will be very less, they will not be performing good at all. So, likewise, whenever any kind of the joint is made, say the by welding process, whether it is solid state joining or by the fusion welding process, see we see lot of the undesirable metallurgical changes. Okay. These undesirable metallurgical changes not in the weld zone, but also in the heat affected zone that will be occurring. And because of this heterogeneous microstructural aspect, the corrosion resistance of the different joints become different. So, we have to see that if the joint has to work under certain corrosive media in contact with the corrosive media, then your joint must be able to resist the corrosion, otherwise localized selective corrosion will lead to the premature failure or poor performance, reduced life of the joint, okay, and that in turn will reduce the reliability. There is another aspect, reliability. So, if the component or the product where the joints are being made, so if there is no major threat to the life or there is no major threat to the loss of property, if this no threat to the life or to the property, then maybe the criticality is less, okay, criticality is less. So, we may survive, joints of the little lower reliability can also be good enough, okay. So, but if life and the property both losses can be significant, like in pressure vessels, okay, like in aircrafts. If the things fail, then there is a huge possibility of the great loss of life and property. So, we need so these are extremely critical conditions, critical applications. We need to ensure that whatever the joint is developed, that performs during its service and the reliability of the developed joint is high. Say for example, if you want to develop some nuclear reactor, then the quality of the joint must be high, because any kind of the disaster, failure of the joint will lead to the disaster. So, the quality of the joint must be very good. So, what we do, we prefer developing the quality joints, either go for the solid state joining if it works, otherwise go for the low heat input process like the tungsten inert gas welding, that is one of the fusion welding process. Okay. So, now we have to see metallurgical compatibility. Okay. So, if the components to be joined, two components to be joined, A and B are compatible with each other, then certainly we can use any kind of process as per our the choice, like it can be mechanical joining, it can be brazing soldering, it can be adhesive joining or solid state joining, fusion joining, anything. But if A and B are not compatible with each other, say metallurgically, or their connection is bringing lot of increased tendency for corrosion, then we need to see how to develop this. Say A and B are not compatible, say from the corrosion point of view, then we like to see that how we can isolate them from each other using, say, even adhesive joining will be good if it works with regard to the service conditions. If that is not the case, then we have to see that A and B are not compatible with each other, then we have to see that they do not come in contact with each other. So, what we do between A and B, we put C, which is compatible with each other, compatible with A and B both. So, it results in the joint which is compatible with each other. The weld zone is compatible to both A and B. Even if this is not the case, then what we do, A and B which are not compatible with each other, then what we do, try to use the solid state joining, so that the interaction between the two remains minimum and that too at low temperature, so that the related issues, related metallurgical incompatibility issues are do not come up much. Okay. So, so we have to see really how to choose the joint and which type of process is to be used, considering the metallurgical compatibility, requirement of service, or the type of the joint. Then the nature of loading, it can be static or dynamic. As I said, hybrid joining offers very good fatigue resistance as far as the, like say in spot welding if we consider. So, spot weld joints are very low in terms of the fatigue resistance, but if we develop the hybrid joint like your adhesive joint coupled with a spot welding, our fatigue resistance will be very good. That is just one simple aspect. If we go for the fillet welding joints using the fillet welds like this, okay, then these joints do not perform very good under the fatigue conditions. So, what we try to replace is, if possible, go for the butt joints like this, so that the performance of the joint under the service conditions is very good. Then the metal systems to be joined. There are many metal systems like which are heat sensitive or not so heat sensitive. So, if it is heat sensitive, then we try to prefer to use the approach in which heat is not applied much. Okay. So, it can be solid state joining, or it can be your adhesive joining if it works, or it can be, then if it is still, if it is not working, then we will go for the laser welding or electron welding. So, depending upon the heat sensitivity, if heat sensitivity is high, then we prefer to go for those processes where possibility of heat application is very limited. Okay. But if the heat sensitivity is not so high, then we can simply go for the fusion welding process or any welding process where the joint can be made without much difficulty. Okay. And among all these things, what we try to see, whatever the joint is developed, that must give the desired performance, desired life, and it also, you see, economical. So, economy significantly dictate the choice of the joint and the approach to be used for developing the joint. Now, here I will summarize this presentation. In this presentation, basically I have tried to give the outlook or overview of the joining process, the need of the joining, the different types of the joining, what are the factors to be considered for development of joints. Thank you for your attention.